Okay, students, now I think you are connected. Okay, so no issue at all right now. Uh, there was, I'm having some problem to start with it, but the problem is sorted out. So I think everybody has joined. Let me adjust my screen. Okay, so finally it is joined. So student, today we are going to see the magnetic effect due to current carrying circular wire. Okay, till yet what are the things we have observed? Am I audible, student? You can write in text and you can say that yes or no. Please, am I audible? Very good afternoon, students. Uh, Please write that am I audible? Picture is okay. Okay, good, very good. So actually, I was trying to set up all the things, but little late. That's okay. We can go for more 5 minutes or 10 minutes for the session. Okay, very good. All are writing yes. Okay. So why I am connected? So I can show you some demonstration also with the activity. Okay. Yes, Rameshwar. We are writing I'm audible. Okay. So that is okay. Now we are going to start with the session. Okay, almost the things I have done the setup. Oh, just 1 more minute I will take. Okay. So up to now, student, we have discussed about magnetic field lines, and magnetic field due to the current carrying conductor, the properties of magnetic field lines. So many topic we have observed. No? Last class through the activity I tried to clarify you. When you have a straight wire, the current carrying wire, then how we can find out the magnetic field around this wire. So uh, I clarified on that time if we have the wire, then the direction of magnetic field by right hand thumb rule we can find out. If current is moving in upward direction, then what will be the direction of magnetic field? The direction of magnetic field will be along the direction of curled finger. So here you can see my curled finger is in anti-clockwise direction. So this thing already we observed. Now in today's session, we will try to know magnetic field due to the current carrying circular wire. Student, it's simple to understand in terms of the straight conducting wire. Now, if suppose this wire is not the straight, but if it is in form of circular loop, right? This way, as we can see here. So, what will be the magnetic field and what will be the direction of magnetic field? How we can know about it? Is this figure is clear to you? Is it visible? Okay, some of you are writing that voice is not clear. Okay, just a minute, students. Now, am I audible to you? Okay. The picture, video is not so clear. From laptop, actually, let me adjust the focus. Okay. Now, I think it is audible because when I'm moving from the mic, no? So, so now you can see this figure. Okay. We will try to learn the pattern of magnetic field lines. Okay. Produced around the current carrying circular loop. Suppose student, this is a current carrying conducting wire that is in form of circular loop. Okay. So what will be the pattern of magnetic field? Now, for to understand this thing, we can just take a small length of or the part of this wire. Okay, like see, suppose this is the wire in the form of circle, no, and we can connect through the source through like this. So, how the magnetic field will be there? No, what will be the direction of it? So, in this case, what we can see, suppose this thread is showing the direction of current, no, means it is coming to this side and moving, and means the direction of flow of current is from right hand side to left hand side. So what the right hand thumb rule tells here, see, you can see here, my thumb is showing the direction of current. So what will be the direction of magnetic field here? See, this will be then a circular form now here. Means this will be kind of loop. When you will see this section or this part of the wire, then where will be the direction of magnetic field? This way. Yes. Similar way, when the current is coming from this part and going to this way. So see, what is the direction of current? This. The thumb is the direction of current. Na? And see the magnetic field direction? This will be the direction of magnetic field. Okay. Some are saying picture is not clear, but voice is not clear. Okay. Now, I think now it will be clear. So, now see the direction of current. Na? This way the current is moving, and direction of magnetic field will be this. So are you getting this? Now you understood? Please write yes or no. Are you getting? Okay, yes. So I think the different color is not visible from this part. Uh, Here, so the diagram it is working, no? But current is moving from this to this way. See, current. And the magnetic field will be in a form of circular loop everywhere you can find out. So this will form the curved lines. So at the exactly middle point is all. So this and this point like this means this will be somehow also a circular form, and the direction will be this one. Another question arises, no? What the question is that what are the factors on which the strength of magnetic field depends on? Okay, what are the factors? We can observe here the factors. The very first, since it is a form of circular loop, no? And the current is flowing. So the very first, magnetic field will be denoted by B. So the much amount of current will flow, then the magnetic will be that much. Means the magnetic field will be directly proportional to the current flowing through it. And another, no, you will see that near to the wire, the magnetic field will be more. But as soon as you will move away from the length or the wire, the magnetic field will reduce. That already I have shown you in the activity. So it means that it is inversely proportional to distance from the wire. If it is a single loop, no. Now this wire, see, this is the wire. Now when you increase the number of turns now of this wire, means this is a one turn, then this is a another turn, and similar way when you increase the number of turns, that particular time the magnetic field will increase. It means that the magnetic field is also proportional to number of turns of circular loop. Is that okay? So this is the factor on which the magnetic fields depend on instruments. And the direction you can find out by either right hand thumb rule or also by placing a magnetic compass. Right? So this is the concept for magnetic field due to the current carrying circular wire. Now we will try to know about solenoid. Do you know, student, what is solenoid? Do you understand what is solenoid? You can write in comment section. I'm just waiting for you. Do you know what do you mean by the solenoid? Any one of you? What is solenoid? What is this? Do you know it? Okay. If you are not knowing, no issue at all. See, when the circular loop you observe, no? So when you have a multiple loop, no? Suppose this is a wire and this is a simply we are taking to just forming the loop. So this is the thing, no? Long cylindrical coil consisting of large number of turns. 1 minute, students. Long cylindrical coil consisting of large number of turns of an insulated wire. This wire can be made up of copper also, as it may be visible to you. Okay, so long cylindrical coil consisting of a large number of turns of insulated wire is known as a solenoid. Okay, so this behave as a simple bar magnet. We can also find out how and what will be the direction of magnetic field of it. Okay, so just before this concept, we observed about the circular loop, right? So the magnetic field are like this around this wire. So you see here the multiple number of loops are there, na? So you can imagine that definitely the magnetic field strength will be more here. Okay, some of you are writing in comment section, that is okay. Which contain a strip of wire around it, very good. A cylindrical coil of wire acting as a magnet when carrying electric current, okay. Now to be like long, tightly wound helical coil of insulated metallic wire, okay. Good. So now it means that you understood what is the meaning of solenoid. Okay. Now, how can we find out about the direction of magnetic field? Okay, and we will also show you, means I will also show you how it behaves like a bar magnet. So, very first, we want to know about polarity as we are comparing with the bar magnet. So, it should possess the north pole and south pole. Okay, meaning is clear. Okay. Now suppose the current is flowing from this direction and coming out from here. Okay. So it is a long helical coil, no? Now what will be the polarity? This can be determined by these two things. What is first? See, you have to notice about the direction of flow of current. Na? Very first, if direction of flow of current is in the clockwise direction, okay, so it means that it will be the south pole. Similarly, if the direction of flow of current is anti-clockwise, means current is moving in this direction, then this will be the polarity of north. See, this thing you can observe and you can remember also. See, it is showing like clockwise, it is showing like anti-clockwise. So anti-clockwise if current is flowing, that will be the north pole, and if the current is flowing in a clockwise direction, then it will be the south pole. Now, here the magnetic field we can observe now. For this loop, definitely it will be like okay, like the circle. You know that the magnetic field lines outside of the magnet moving from north to south and inside from south to north. Now, so what will be the direction of magnetic field lines here? So definitely it should have for just like if you have the bar magnet here, north and south. You observe now, and inside it will be the uniform magnetic field from south to north. So isn't it the pattern is very similar to the bar magnet? Now the main thing is that which will be the north pole, this side or this side? What will be the direction of magnetic field line? How we can say? So we can decide by these two. Okay, if it is anti-clockwise, it will be north. If it will be clockwise, it will be the south pole. Now we can observe this wire practically. Like suppose I am keeping this wire like this. No? Okay, because this board is in two dimensions, so exactly we cannot find out. No. Now here this wire we will try to observe. Now suppose this from this side the current is entering as I have shown in the board. So you have to observe this thing. See the direction of movement of current. सो जल्दी जल्दी बताओ, ये क्लॉकवाइज करंट मूव कर रहा है या एंटी क्लॉकवाइज? सी एंड टेल मी फास्ट इन कमेंट, कमेंट फास्ट। ये क्लॉकवाइज है या एंटी क्लॉकवाइज है? जल्दी बताओ, ये क्या दिखाई दे रहा है? ये क्लॉकवाइज है या एंटी क्लॉकवाइज है? Some of, okay, anti-clockwise, anti-clockwise. Two of you have written clockwise. Shreyas is writing clockwise. See, it is a like this current is moving, ना? तो घड़ी ऐसे मूव करता है या घड़ी ऐसे मूव करता है? So this is an anti-clockwise. Yes, it is an anti-clockwise. This is not a clockwise. You see clearly it. This is a anti-clockwise. Right? So if it is anti-clockwise, means with what pole it consists of? ये कौन से पोल को बताएगा? Anti-clockwise. See there in board and tell me fast. Anti-clockwise मतलब कौन सा पोल को रिप्रेजेंट कर रहा है? Very good, North Pole. So what then? How we can show that? Means if it is a North Pole and it is a South Pole. So the direction what you can observe will be this one. Okay, the direction of magnetic field will be this one, and inside it will be south to north. So got the concept? Got this concept? How you can find out the direction of magnetic field in a current carrying solenoid? Okay, good. So you are understanding the things now. Very good. Now I will practically show this thing now. Just wait, hold 1 minute now, students. I'm showing you. Okay, this is visible to you. This is a magnetic compass. Okay, now is the needle visible to you? Is its needle visible to you? Please write yes or no fast. Okay, you can see the needle. Very good. Now, see, this is a solenoid, right? Now, see, it is producing the magnetic effect or not, right? See, when I'm connecting this coil, okay, solenoid exactly, with the cell, then see, are you seeing the deflection? See, are you seeing the deflection? So it means that this is producing definitely the what? Magnetic field. Now we can identify it is a north polarity or south polarity. Yes. So when you see this thing, no? See, this is what? Anti-clockwise. Are you seeing this? Or clockwise? Tell me fast. It is a clockwise or anti-clockwise? See, when I connect it, no? See, it's repelling. This is the north pole, and this is also showing the north pole. It means north and north are repelling, means this is behaving as a bar magnet, and this producing the north pole. And anti-clockwise already we have written the north pole, and it's repelling. That verifies that the current produced in the anti-clockwise direction is a north, but just opposite of it will be the south pole. Okay, so this is a demonstration. Now student, uh, this same solenoid, this same solenoid, when it will consist of soft iron core inside it, okay, that time it will be known as a electromagnet. Okay, so whenever a strong magnetic field produced inside a this solenoid, it have the capability to magnetize the magnetic material. And same thing happen when you take this kind of solenoid, and when you insert, or if inside it or anywhere, when you form the solenoid and enter, no, under this nail, it will behave as a magnet, what we call electromagnet. I can show you the demonstration also. Just hold on. Are the pins visible to you? Might be, it will be visible to you, so we can see. But when you connect it to the cell, no, this will behave as a magnet. You can see it's attracting. Okay, when you supply the more power, see, it's attracting, means it behaving like a magnet. Yes, one of you are asking that, sir, is any other material which we can do this experiment? Yes, definitely we can do the experiment. Any magnetic material, with that we can do the experiment. Simply I have taken the iron, or definitely you can take the alnico, or the different kind of other magnetic material also, no? So what is electromagnet, student? What is electromagnet? What you learned? What is electromagnet? Please define. Yes. What is electromagnet? See, what we can say that this is solenoid, no? When the solenoid consists of what? Any magnetic material in its core, it is known as a electromagnet. Sometimes the question can be asked, why we prefer the soft iron core in a electromagnet, not the steel? No. So basically that answer is what? When you use the steel or the another kind of material, no, then what will happen? It will work as a magnet when the current is supplying to it. But when you remove the current supply, after that also it will work as a magnet. It will not lose its magnetic property. But in case of soft iron core, as soon as you remove the electricity, it will become the simple iron. Okay, soft iron. It will behave as a, and it will not behave as a magnet. That's why soft iron are preferred to make the electromagnets. Okay, so There are some homework for you that you can write, like why soft iron is used, not the steel. And similarly, another thing is that what are the difference between the electromagnet and permanent magnet. Okay, I'm just telling you. After that, you can go down. See, now the current is flowing in anti-clockwise. It is not flow. When the current will flow into the clockwise direction, what will happen? It will become the south pole. Means polarity of the electromagnet can be changed, but polarity of the bar magnet cannot be changed. Okay. The strength of electromagnet you can increase or decrease, but the strength of permanent axis is fixed. So on you can find out the differences. I hope that you are benefited from this today's session. So just go through this and revise the same thing. Okay, we will learn the next day regarding Fleming's left hand and right hand rule in terms of electric motor. Okay, so have a nice day, student. Bye for now. Okay, some of our writing topic is clear. So is it everybody clear the topics today? Today's session topics are clear to you? Okay. Bye, students, and thank you.